There. We've got some weird looking shape here. We need to work out what the circumference or the perimeter of this shape is. Now obviously you can see here it's not a regular shape, it's not a rectangle or a circle or anything like that, but it's basically two lots of shapes, or in this case three lots of shapes being merged together. Technically speaking two, but we'll come to that very shortly. The first thing I notice here is that we've got 23 millimeters and 2.8 centimeters. Now, if we don't go either one at once, we could either keep them both in centimeters or both in millimeters. Either one we'll get will be probably in this case we might keep it in centimeters. So, just the cases. I just want to go and demonstrate how you could do either or. So let's just say we wanted to get millimeters into centimeters. Well, there are 10 millimeters in every centimeter. Now that little symbol there you might see me see there, there's the three little dots. That means therefore. It saves me having to write therefore. It's often used in maths to say, well, if this is one thing, therefore this will be the other thing as well. So 10 millimeters in every centimeter, therefore if I did millimeters, so therefore millimeters divided by 10 equals centimeters. So here we go. So 23 divided by 10. Now you might think, some of you might remember how to divide by 10 very easily, some of you might not. I'm not judging, but either way, we've got to figure out how to do this. So, the easiest way to do that, whenever you've got a whole number like this, imagine, if you will, there's a little decimal point just on the end there. Okay, every whole number has the decimal point at the end. So if there's no if it's not like 1.5 or 2.68 or whatever the case might be, if it's just like 3, then there's a little decimal point right at the very end, right on the end of the number. It's a little hidden right there. You might sneeze and it might fall off. Either way. So when you're dividing by 10, when you're dividing by, the little invisible decimal point moves 1 to the left. Okay, because it's moving, we're dividing by 10. So this is equal to 2.3. So therefore the 23 millimeters is actually the same as saying 2.3 centimeters. Okay. Now, let's move the other way around. Let's go the other way. Let's say if I want to make that 2.8 centimeters. Now, what do you think I'd have to do? So, I imagine if I went from millimeters to centimeters, I had to divide. If I want to get from centimeters to millimeters, I need to go the other way around. To get this from centimeters to millimeters, we need to multiply by 10. Why? Because again, there's 10 millimeters in every centimeter. So for every 1 centimeter, that's 10 millimeters. So if I had 2 centimeters, that'd be 20 millimeters. 2 times 10 would be 20, that kind of thing. Anyway, so centimeters to millimeters, so I've got 2.8 times 10. Now I've got an actual decimal point here, so we don't need to pretend there's a decimal point because it's actually there. So when I multiply by 10, that decimal point 1 to the right equals 28 millimeters. So there we go. So I can change that to 28 millimeters. It doesn't matter which way you go. You can go either way, whatever's easier. If you don't like divisions, then fine. But nonetheless, either way would be perfectly fine. I personally am going to go through with centimeters. Okay, so now we're going to work out the perimeter of this friend. So we've got a sort of a flat bit, and then we've got some round bits. Hopefully, if my picture doesn't look too much like it's an ice cream, poor little ice cream in summer, then we can see we've got two semicircles, and we've got a bit of what would seem like two sides of a rectangle. Well, I imagine to find the perimeter, at least this bit and this bit should be easy, because it'll be 2.3 centimeters from here to here, and also from here to here. Now, of course, like I said before, really we should have a little line there and a line there. but nonetheless it's worthwhile just remembering that this side here and that side there are the same. So 2.3 centimeters plus 2.3 centimeters. Now, we've got this curve and this curve. Now, the great thing about the curve and the curve is if I put them together, it makes a circle. So therefore, that side and that side, put them together, that will make a circumference of one whole circle. And the circle, in this instance, has a diameter of 2.8 centimeters. So what would be the radius then? Go on. Remember, what was radius? Radius is half of the diameter. So therefore, 1.4 centimeters. So therefore, the circumference Now from this point, since we're going to use a calculator for this question, I'm actually going to use the pi button. The pi button is based on the calculator, has every single digit of pi in it. Every single one to the 50 billionth one, whatever the case might be. So therefore, it is the most accurate one that we can use. Well, unless we had some sort of supercomputer. Do you have a supercomputer? I thought not. Suffice to say, we can go and press 2 times pi times 1.4. So I'm getting 8.796, blah, 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 blah. Now, in the question, it might say to how many decimal places. So usually you check for that, so it might be 3 decimal places, or whatever the case might be. Since everything seems to be to 1 decimal place according to our measurement, I'm going to make our answer to 1 decimal place. In year 12, usually you keep things to what's called the real answers, unless it's specified. So at year 12, they will specify how many decimal places you use. And in sciences, and particularly chemistry, they will also tell you how many significant figures, which we'll talk about another day. Suffice to say, I've got 8.796. Now, of course, it's not 8.7, would it be? Because 796 centimeters. If I'm rounding, I have to look at the next digit and go up 1. So it'll be 8.8 centimeters. So, the full perimeter is 2.3 plus 2.3 plus 8.8. Okay, and we can pop that in to our calculator. I suppose I could work this out in my head, but who needs a brain? This is equal to 13.4 centimeters. And there we go. So now we found the perimeter of an obscure shape like that. Any other shapes will also work in very similar ways.